One of the first things I did when I got the machine was to take it apart, get rid of all the chips and start cleaning it. This had seen probably 30 years of dirt and grime, so it was quite dirty. Initially I didn't really understand how it was all assembled. Later on I found out that you can basically take out 4 bolts and you can take the whole enclosure off. But yeah, lessons learned, I guess. When it comes to all the nook and crannies, I just took some, I believe this is some kind of tool which you actually use to take off springs on like cars or something like that. I just put that inside and scraped it all off. That worked pretty well. But there's a lot to take apart of this machine, there's a lot to clean on this machine. Going to go off. So this machine came from a CNC machining facility. They actually got rid of it because the ATC stopped working. Before taking this all apart, I tried to get it working, but unfortunately I was not able to.
There it is.
There was some electronics damage which I was not able to repair, and getting it repaired was ridiculously expensive. Because I didn't want to be dependent on basically 30 years old hardware and not being able to fix it myself, I decided to basically retrofit this whole machine. Just used some store-bought degreaser, sprayed on everything, let it soak in for a bit, and then just sprayed it off. Of course, this all being steel, I had to dry it off to prevent any rusting. I must say, so far, no rust has come on it, so this steel must not be very, how you say, susceptible to rust.
A few moments later.
Now we're getting into the electronics. I just took it all apart, as I said before, like this is 30-year-old stuff. It actually worked pretty good at the time, except the ATC, which again I wasn't able to get rid of. All the copper that came out of this, I returned to the scrapyard, and I got like $400 worth or something like that. So it was actually, it was actually pretty good. So it's empty now. So I play this out. I'm going to clean all this grime off. As you can see, especially back there, is where the fan unit like blows in from like this side, went up past the servo motor controller, and then it went out here. But you see, after like 30 years, there's a lot of gunk. I use this random little super degreaser. I used it before, works really well, together with a steam cleaner. This is how much muck. So I thought I just filmed a video of me cleaning this with the Parker steam water jet. So here I'm scanning the internals of the electrical cabinet to make it easy to basically design a new internal components for this. This scanner is not very good, so it was quite a bit of hassle, but in the end the result was pretty good. This machine has a lot of weird angles, so measuring by hand was a little bit of a pain. The detail which I got here was not very good, but it was good enough to basically redraw the cabinet. So then I imported an Fusion and basically measured a few things and copied the design. I later on measured it on the machine and it's actually as good as it gets. Everything fits, so that's all that's important. So the servos that I'm going to use is the Delta B3. I'm doing everything on EtherCAD, well, as far as what is possible, to make the connections way simpler. I'm putting on some extra servo drives in here because I want to be prepared for 4th and 5th axis. Initially, I actually meant to use this for the ATC, but after quite a bit of testing later on, that was just kind of stupid. I just put a DC geared motor on basically the carousel of the ATC, and later on I put I just used the servo still on the arm. Which again is way overkill because initially it was just made for a basically geared AC motor, but I like to have a little bit of control in it. Hey guys, for those following my retrofit of my Kitamura from 1992, I've just received my Delta servos, followed the instructions by Centroid, and about a half hour later I got them running. What you see now is them running a sample program. I think it's some Pocket or something like that. These are 1 kilowatt motors for X and Y and a 1.5 kilowatt motor for Z. These are all Delta B3s running absolute encoders. As you can see here, the feedback is quite direct, it works quite easy, and overall I must say this has been a far smoother implementation than I had in the past with Linux CNC. Anyway, if you're interested, keep following. Bye bye. Extra hole here, and it's kind of difficult to show, but if you put this inside here, let me see, there's a set screw, and if you turn it slightly, then here you get the side screw. Is this perfect? Probably not, but well, it's something, right? So now let's go have a look at the servo drive. Here are the connections, just the normal things you expect: earth, the motor connections, connection for a brake, ground connection, and an incoming connection, 380 volts. In the front has a few connections. Here's a quick image of what it is. Oh, this looks quite pretty. So let's go around. The model number is S3A. You can actually open this up, I think. So you can open this up and you have the buttons so you can control stuff. So on the side, let me turn it over. The model number, the THS3A-H37F, whatever this stands for. 380 volts, 3-phase, 50 to 60 hertz, 20 amp. So that's quite a lot of power. As you see, this motor is only 8.7 amps, so it can almost do double this. So let's say a 7.5 kilowatt motor. So that's quite impressive. The construction, this is plastic, this aluminum. Here on the side, custom aluminum extrusion, cooling fans. On the back, they mounted a fan which sucks air in here, presumably, or blows it out, I'm not sure. And then either it goes up this or it goes inside and then out. Unit looks like quite good quality, especially considering in a status like this, because it came as a set. You probably only paid about $100 for this. And for a spindle drive of 7.5 kilowatts, which has spindly orientation, can do all kind of encoders, because this one is, well, it's Chinese, but this means sine, cosine. Anyway. So sine, cosine, it can do the normal quadrature encoders, etc. So it's quite impressive.